Hey everyone, this video focuses on how to program logic sequences in Proficy Machine Edition version 9.5 for the use of programming Emerson RX3i PACSystem controllers. And logic sequences are extremely popular and found within almost every industrial automation environment in almost every industry, including food and beverage, pharmaceuticals, oil and gas, etc., etc. Now, logic sequences are basically a series of actions required to be taken in a specific order in order to achieve a desired outcome. And the sequence comprises of individual steps, and the sequence itself can be cyclic or it can be linear in nature. Now, a cyclic sequence basically moves through the sequence steps, and when the final action is performed, the sequence automatically repeats itself until otherwise commanded to stop. Versus a linear sequence, whereupon the sequence moves through its sequence steps, and when the final step is performed, the sequence stops and remains stopped until it's been manually started up again through an operator command or maybe through some sort of logic conditionary statements. Now, there are four critical elements of a logic sequence. We have, of course, our start and stop commands, we have our sequence steps themselves, then we have the sequence step transition conditions in order to move from one step to the next step, and of course the outputs from each sequence step that initiates the respective actions to be performed. Now, let's look at an example sequence for the filling and draining of a water tank, which we're going to be modeling shortly in Proficy Machine Edition. Now, suppose we have a tank. It's got two valves, a fill valve and a drain valve, and a mixer. And an operator is required to define a fill set point and a drain set point. Now, let's suppose that an operator presses a physical start push button to engage, so that means to start the sequence. And the first step is for the PLC to start a mixer. Then once the mixer is started, the second step is after 5 seconds, the PLC will command a fill valve to open in order to start filling the tank with water. And then for the next step, once the level of the tank rises to the fill level set point, then let's say the PLC commands the fill valve to close because we've reached our desired level. At that point, the PLC will move to the next step to then open a drain valve to begin draining the tank of water. And the next step is that once the level falls to the drain set point, then the PLC is going to command that drain valve to close. And then for the next step, after 10 seconds, the PLC commands the mixer to stop, and the sequence is commanded to stop. And we want it such that any time during the sequence, doesn't matter if we're in step 2 or 5 or whatever, if an operator presses a stop push button, then both the fill valve and drain valve will close, the mixer is stopped, and the sequence ends. So I know there's a lot here to take in, but we're going to step through this one at a time. So let's now jump to Proficy Machine Edition. And here what I've done is I have a very simple program with one ladder diagram block, and in this block all I've done is I've just prepared comments in different rungs indicating the expected steps that are to be taken for our logic sequence. Now, beginning with our start and stop logic, let's go ahead and define the start and stop conditions for our logic sequence. So the first thing I'm going to do is the easiest thing. I'm going to start defining a stop push button to stop our sequence. So we're going to call this stop underscore sequence underscore PB just for the stop push button. And let's suppose that once the stop push button is pressed, we're going to stop our sequence. Now, for the sake of tracking our sequence and the step we're in, let's assume we're going to be using an integer to track those steps. And let's assume that if the integer has a value of 0, that means that the sequence is not running. So if we're going to basically write a 0 into our sequence step to track what step we're on in the sequence, and if we write a 0 to it, that means we want to stop the sequence. So let's just say if you press the stop push button, the sequence ends. However, if we press, say, a start push button, then we want to start our sequence. And in this case, we only want the start push button to take effect if our stop push button is not pressed, and we want to do a quick check to see if our sequence has even started. So we want to make sure we're not equal to 0. We want to make sure we are equal to 0, which means that our sequence is not running. And if it's not running, then we can start it. So if our stop push button is not pressed and our sequence is currently not running, let's do a move integer. We'll use a move integer instruction to move a 1 into our sequence step to begin our sequence beginning at the very first step. Now, for the sake of our push buttons, let's assume that once we get our commands through our push buttons, we want the logic to execute, but then we want to write a 0 again to our push buttons. That way they're not maintained. They're not constantly being held in and affecting the logic. So what I'm going to do is I'm going to skip to the very bottom, and I'm going to create a few rungs here, and I'm going to just put some reset coils. to reset our commands back to 0, beginning with our stop command. Once the command is received, we want to just set it to 0, and then same thing with our start command. Now let's move into the second step, the first step, the very, very first step in our sequence, which is to command a mixer to start. So very simply, what I'll do is I'll copy this equal to integer instruction, and we're going to do a check to see if our sequence step is equal to 1. And if it's equal to 1, then we know we need to command a mixer to start. So what I'm going to do is just create a horizontal wire, and I'm going to, on the end of this horizontal wire, I place a coil, call this mixer run. And that just means that I want, whenever this variable is true, I want the mixer to run. Now, based on our logic sequence, we always want the mixer to run whilst the sequence is running. We never actually stop the mixer intermittently within our steps. So we have to be careful, because if we were to move, say, to step 2, based on this existing logic, the mixer run status would be removed, or rather the run command would be removed, because now our step would no longer be equal to 1. So what we have to do is actually latch in this status. So what I'm going to do is, if our mixer is commanded to run, and we are not equal to 0, our sequence step is not equal to 0, and our sequence step is greater than, in this, actually, you know what? Let's just really simplify this. If we are not equal to 0, that's fair, but technically, because this mixer is always running, let's assume that we are greater than integer 0, meaning as long as we are in the sequence and we're not stopped, our sequence is not stopped, let's keep this mixer running, assuming we've commanded it to run. So very simply, that's just latching in our mixer for the remaining sequence steps. And now we have to engage our transitionary condition, if you recall. That's one of the 4 elements of a sequence. So as long as we have our mixer is running command, and we are in step 1, and we have our mixer running command, then we can move to the next step. In this case, I just simply use a move integer instruction to move us to the next step of the sequence, which is step 2. So I'm going to move a 2 into our sequence step, and now we're in step number 2. So let's move now to step 2. Step 2 is after 5 seconds, the fill valve is commanded to open to fill the tank with water. So we do a check. Is our sequence step equal to 2? If it's equal to 2, we start a timer. So here's our timer, and I'm going to call this timer ton_step 2 with a 5-second preset time, so that's 5,000 milliseconds. And let's just use ton step 2 et so we can see our elapsed time. Let's feed this in such that as soon as we're in step 2, the output is energized, and now we have power passed to our ton. And if we have power passed to our ton, it's going to count for 5 seconds, whereupon we're going to open up a fill valve. So we're going to call this fill valve open. And if you recall, just like the mixer, we want to keep this fill valve open until we stop it later on in our logic. So what I'm going to do is, if we have our fill valve open, meaning we've asked the fill valve to open, we've commanded it to open, and when does the fill valve get commanded to close? When the level of the tank rises to the fill level set point, the fill valve is commanded to close. So that means after step 3. So we have to do a quick check. If we are not equal to step 0, and our fill valve, and our step is less than step 4, that means that we haven't moved to step 4, meaning the fill valve is commanded to close, because that would have been the transitionary step from step 3. So we're going to do like this, go like this, and we're going to basically latch this in. So just to reiterate, if we're on step 2, 5-second timer begins timing. When it elapses, fill valve is commanded to open. Then later on the logic, if the fill valve is commanded to open and we're not equal to 0 in our current step of the sequence, meaning the sequence is not running, the sequence is running, we're not equal to 0, and our current step is less than 4, which would have been the action taken to, once the level of the tank rises to the fill set point, then we keep the fill valve open. And then finally, what we're going to do is, if we're on step 2, and we have that fill valve open, now we've commanded to open, we're then going to move to our next step, which is step 3. Okay, now we're into step 3. So there's our transition. In step 3, when we're in that step, so let's copy this equal to integer instruction and just see if we're in step 3. If you recall, the drain valve, when the level of the tank rises to the fill set point, the fill valve is commanded to close. So what we're going to do is we're going to do a greater than or equal to instruction, and we're simply going to check to see if we're in this step. We're going to see if the level, we'll just use level, if the level of our, the level in our tank is greater than the fill level set point, then we move to step 4, whereupon the drain valve is commanded to open to drain the level to drain the tank of water. But then, of course, once we move to that step, because of this logic statement here, the fill valve will be commanded to close. So I'm going to just simply do a move instruction. Let's move a 4 here. And as soon as this executes and the PLC scans once again, it's going to see that, well, I see your fill valve is open, your step is not equal to 0, but now you're equal to 4, therefore this instruction will evaluate as false, therefore the fill valve will close. So that meets the requirement for step 3. Now in step 4, it just says the drain valve is commanded to open to drain the tank of water. So if we're in step 4, we're going to open up our drain valve. So I'm going to just copy and paste some of this logic. So let's go ahead and just paste this here. Let's call this drain valve open, drain valve open. And if you recall, this drain valve only stays open until the level falls to the drain set point. So in the same regard as we've done before, we're going to latch in the condition until, so here, let's call this drain valve open, as long as our sequence is running and we are not less than step 6, and we are less than step 6, then we keep the valve open, because as soon as we move to step 6, meaning the level has fallen to the drain set point and the drain valve is commanded to close, then the drain valve coil is de-energized. So make sure that's a 6, and let's go ahead and just make that branch. And then finally, if we are in step 4 and our drain valve is open, we move to step 5. So there's our step 5. Now step 5, when the level falls to the drain set point, the drain valve is commanded to close. So this is going to be basically this logic here from before when we were filling the tank, except we're now in step 5. And in this case, when the level is less than or equal to, and I'm sorry, this should be a real instruction, as we're using real values, real data types for these variables. So we'll call this drain level set point, and let's ensure we have the real used here as well. Okay, so when we are in step 5 and the level is fallen to or below the drain level set point, we move to step 6, and as soon as we're in step 6, then we're going to see here from above if the drain valve was previously open and we're not in step 0, and we are now no longer less than 6 because now our level has fallen to the drain level set point, then this coil will de-energize to close our drain valve. Now that we've moved to step 6, we can see after 10 seconds the mixer is commanded to stop. So in the same regard, we're going to just copy and paste this. If we are equal to 6 in our step, we're going to engage a T-on instruction, which will be our T-on _ step 6. And in this case, we'll put 10 seconds for our mixer with a T-on step 6 elapsed time, so we can just very easily track it. Oops, and some horizontal wires. And in this case, very easily, all we need to do is as soon as we finish step 6, we move to step 7. Because if you recall, after 10 seconds, the mixer's command is stop. But the thing is, once we move to step 7, we finish the sequence. So if we finish the sequence, then we're no longer latching in that earlier rung where the mixer is commanded to run, and it will just disengage. So after 10 seconds, we move to step 7. As soon as we are in step 7, we move to step 0, and if we're in step 0, we can see here at the earlier logic where our mixer is commanded to start, because our mixer is previously running, and we're now no longer greater than 0, we're going to set our mixer running to off. Okay, so that looks good to me. Let's go ahead and go online with this code. So we're going to connect to our PLC, and I'm going to download this project file to our PLC. So we're going to do programmer mode, and then the download command will be available to us. I'm going to click download, and I'm going to just download to our target. And now that I'm downloaded to, our controller is currently running. We are no longer running our sequence. And just before we engage our sequence, let's just confirm our levels. Let's just say our level is 0, the drain level is 0.5 meters, and the fill level is, what do I have it at? 3 meters. Okay, that's fine. So let's just recap. If I click the start command, you'll notice I just clicked F12 to start our sequence, and because of that later rung where I use a reset coil to de-energize the variable for start sequence PB, then this would have returned to 0, but that's okay. Not before we've wrote a 1 to our sequence step, and I think we just lost that, so let's quickly go to 1. Now we move a 1 to the sequence step. We moved a 1, our mixer is running. When the mixer is running, we move to 2. After 5 seconds, we move to 3. In this case, our fill valve is commanded to open, which it is. Once our fill valve is open, we move to step 3. In step 3, we're waiting until the level is greater than our fill set point. So right now it's not greater than, so we're not moving to step 4. But as soon as I write a 3, so greater than or equal to, we can see here we've moved to step 4. Step 4 is executed. Our drain valve is now open, and we've latched it. And as long as we're less than step 6, we're going to keep it latched. Now, after that, it's been latched. We move to step 5, which is where we're currently in. Since we're in step 5, we're now waiting to see if the level is less than the drain level set point. So I'm going to make less or equal to, excuse me. If I make it 0.5, we move to step 6. In step 6, which we're currently in, we wait 10 seconds. And after 10 seconds, we write a 7 to the sequence step. Then once we're in step 7, we write a 0. So what should happen is we should see a 0, and we're no longer in the sequence. The sequence has ended. And if I scroll up, we should see our drain valve is no longer open. Perfect. And our fill valve, of course, is no longer open. Perfect. And our mixer is no longer running. So let's just do that one more time so you can see the sequence moving. So I'm going to scroll down, waiting those 5 seconds. Fill valve is now going to turn, it's going to open. And immediately then, drain valve is going to open as soon as we fill to the 3.0 set point. There it is. Now we're going to drain, and now we're just basically waiting to drain this. So make it 0.5. After 0.5, mixer runs for 10 more seconds, whereupon mixer stops. So I'm just going to scroll up, and a few seconds left, and we should see the mixer stop, and we should then see our step is now in step 0, meaning the sequence is not running. Now, the last caveat here was, if the sequence is running, which it now is, I've just hit F12 to toggle this I.O., let's go ahead and hit the stop command. If I hit the stop command, you'll notice immediately 2 things happen. 1, we wrote a 0 to the sequence step. Now we're no longer running our sequence. 2, our stop sequence push button, because we wrote a 1 to it, if you recall at the end of our rungs, we are automatically resetting this to 0 using a reset coil. And then because our sequence is not running, the mixer is not running, the fill valve is not open, it's closed, and the drain valve is not open, it's also closed. So that's a very simple logic sequence. I hope you found this video informative. Thank you for following along, and stay tuned.